All right, guys. So, the next topic we're gonna do is called the mole, and it's a review to you guys have heard of the mole before, um, but yeah, let's review it. What is it? The way I like to think about it is it's a chemist's dozen, right? And we know what a dozen is. It's a way to group objects, right? So in saying 12 eggs, right? We say 1 dozen eggs. Yeah. Just a way of grouping it together. So we group things in many ways, right? So a duo would be like a group of two, a trio is a group of three, right? Or quartet is a group of four, and so on and so forth, right? But the dozen, right, we use a lot. So we use that as an example. It's a chemist's dozen, right? So 1 dozen is 12 things. But in chemistry, because atoms are so small, right, the grouping is going to have to be a much larger number than 12. And what is that number? It's called Avogadro's number. And the grouping name is called the mole, right? So instead of 1 dozen, it's 1 mole, and 1 mole is equal to 6.022 times 10 to the 23rd. I think I only want you guys to memorize it to, 4 sig figs, okay? So 6.022 times 10 to the 23rd, okay? And that number is called Avogadro's number, okay? I'm going to switch over to the board. So we're going to um, do some example problems, right, to illustrate how to use mole, right, and convert between moles and items. All right. Okay. So, right, that's the analogy. Chemist dozen, right? So regular dozen, right, is 12 items, right? And items here, it can be anything, right? 1 dozen eggs be 12 eggs. 1 dozen oranges be 12 oranges. So it's just anything, right? So similarly, 1 mole of something is 6.022 times 10 to the 23rd. Okay, items. Okay. So let's do some calculations so you see how it works. Okay. Let's do it with dozen first. Okay, so let's say that uh, uh, I want to know how many eggs are there in 2 dozen eggs, right? So that's our unit, eggs, right? Um, So in 2 dozen eggs, how many eggs are there, right? So we have the true statement, 1 dozen is 12. Um, and since we want eggs out, right, as the answer, we need eggs to be on top. So 12 eggs, 1 dozen eggs on bottom. So that dozen eggs cancel, right? Now you have 2 times 12 is 24. Right? And I mean, you guys know doesn't so well, you can be doing this in your head, right? But we got to show the work because trust me, you're not going to be able to do that in your head, right? So we have to say, okay, how do we arrive at 24 using that equivalency, right? Um, now we can go the other way around, right? If I have 144 eggs, right, I'm going to ask myself, how many dozen eggs is that? Okay. So you're going to use the same equivalency, but now you see that you need to put eggs on bottom so that eggs can cancel and dozen eggs on top because that's what you want for your answer, right? So now 1 dozen eggs is on top and 12 eggs is on bottom. Eggs can cancel. 104, 144 divided by 12, right? You see that it's 12 dozen eggs, okay? So you see that in one case, right? Uh, we are multiplying by 12, right? And in the other case, we're dividing by 12. But we don't have to memorize that, right? Remember, unit analysis, we don't have to remember when we need to multiply or divide. We just need to set it up so that our desired unit is on top and what we don't want cancels out, right? Okay. Now I'm going to do it with mole, okay? So you guys see exactly how it correlates, all right? So let's say, since in chemistry is when we use mole, let's switch over to, instead of eggs, we say iron, right? Atoms of iron. So let's say if I have um, 2.0 moles of iron atoms. And I want to know how many iron atoms that is. Okay. So what goes on top? What goes on bottom? Well, what is the equivalency? 1 mole of something is 6.022 times 10 to the 23rd of that thing, right? It's a lot bigger number than 12, but you apply it in the same way, right? So that means mole needs to go on bottom. So 1 mole of iron, okay? Um, atoms, you can even be very specific, right? 1 mole of iron atoms. And on top, that is 6.022 times 10 to the 23rd iron atoms, right? Because that's what you want out. Okay. So 1 mole of iron is you take 2 times that. Okay. So punch that into your calculator. You're going to get 1.2 times 10 to the 24. Okay. And by the way, guys, if you guys are having trouble entering in scientific notation to your calculator, this is the button that you need to be looking for. It's the double E button, and that stands for times 10 to the, okay? Or on some calculator, it's times 10 to the X or something like that, okay? But that's the button that you're going to be using in order to enter in these types of numbers, okay? So if you were to enter in 6.022 times 10 to the 23rd, this is what you should do. 6.022, hit the EE button, and then 23. Simple, right? 6.022 times 10 to the 23rd. That's all. If this was a negative exponent, then you throw in the negative. Okay, so very simple. Okay, so anyways, back to this problem, right? You guys see how um, um, this is analogous to each other, right? That's why we can think of the mole as the chemist dozen, right? Now let's do it the other way around. Let's say I have, um, 7.8 times 10 to the 24 atoms of iron. Okay. And I want to know how many mole of iron that is. So again, I'm going to do the line, right? Well, now this time, mole needs to go on top, right? Because we want mole out. So you're going to say 1 mole of iron is 6.022 times 10 to the 23rd atoms of iron. Okay, so atoms of iron cancel. And so let's do that calculation. 7.8 times 10 to the 24. Divide by 6.022 times 10 to the 23 is, and you want two sig figs here, right? Because of this number. So it's going to be 13 moles of iron. Okay, does that make sense? All right, so let's do a few more examples, okay? And we're going to use different units so you guys can get really well versed with that, okay? But you yourself, you want to do a lot of these problems, right? So in this class, we're going to be doing that a lot, just, converting between moles and atoms or moles and molecules, okay? So that's really, it's one of the conversion factors um, that you're going to be using a lot in this class. All right, so let's do aluminum. How about aluminum atoms, right? So let's say we want, all these are dead. Let's say we have 0.145 moles of aluminum, okay? Right, aluminum is the element, right? And a mole of aluminum, if we were to do this in dozen, okay, 1 dozen aluminum right, would be 12 aluminum atoms. Okay. Now we're asking 1 mole, though, of aluminum is how many atoms of aluminum? Okay. So draw that division line. Okay. Now figure out what goes on top, what goes on bottom. Okay. First, we got to come up with an equivalency. Um, this is equal to that, right? Don't actually start the problem until you figure out the equivalency, okay? And the equivalency is a true statement, right? So you have to clearly say, right? The true statement is 1 mole of aluminum is equal to what? 6.022 times 10 to the 23rd atoms of aluminum, okay? Generate the true statement first. And trust me, this is going to help you. Don't just start putting numbers randomly, okay? You need to make a statement, a true statement that makes perfect sense, right? In 1 mole of aluminum, that's 6.022 times 10 to the 23rd atoms of aluminum. Now, look at that and see what should be on top and what should be on the bottom. Well, we want atoms of aluminum out. So that's got to go on top, right? The number that's tied to atoms of aluminum has to go on top. Okay, and then mole goes on bottom, and the tie, and that's just 1 mole, right, of aluminum. So 1 mole of aluminum cancels out, right? Let's punch it in, and remember to use that double E button for your scientific notation. So I'm punching in 0.145, right, times, okay, multiply because this number is on top. Remember, you hit multiply when the number is on top. If it's on bottom, then you divide, right? So multiply 6.022 double E 23. And I get, all right, let's think about sig figs. How many sig figs do you guys think should be the answer? This is 4, right? And this is 3. So we'll go by least number of sig figs when you're multiplying and dividing. So we'd need 3 sig figs. 8.73 times 10 to the 22nd. Okay? 8.73 times 10 to the 22nd atoms of aluminum. Okay. Okay, let's do another example where we go the other way around, right? Um, just making up some numbers here, right? And you can do this too, right? You guys can do this to practice. Just make up some numbers or grab some problems from the book and just practice, okay? So now we're asking 1.65 times 10 to the 20th atoms of aluminum is equal to how many moles of aluminum, okay? Of course, we already have the true statement, okay? All we have to do is figure out what goes on top and what goes on bottom. So we want mole out. So this time mole is going to be on top. Mole of aluminum is 6.022 times 10 to the 23rd atoms of aluminum. Right? So that cancels out. And now this number is on bottom, right? So you're going to hit 1.65 E, double E, 20, divide by 6.022, double E, 23. Okay. So number of sig figs, let's see. That's 4. Oh, that's 3. So we need to round to 2.74 times 10 to the negative 4. 2.74 times 10 to the negative 4 moles of aluminum. Okay. Is that clear, guys? All right. Well, let's do another problem now, right? But we're going to change it up. We're not gonna, to from atoms to molecules because sometimes you want to know about molecules, right? Let me erase this. Okay. So what if the question is, how many molecules of water are there in 5.4 moles of water? Okay? How many molecules of water are there in 5.4 moles of water? Okay, so we need to come up with an equivalency, right? That relates mole to molecules because we know we need to convert between them, right? We're going from mole to molecules. Okay, so what's that true statement? Well, you know what a mole is. 1 mole of water, H2O, right, is equal to how many molecules of water? 6.022 times 10^23 molecules. Okay. Now earlier when we did Fe and Al, those were atoms, right? And so that's why we had atoms here. Okay, but here by context, water is not an atom, right? We know that water is a molecule. Okay, so you're gonna have to use context in order to see what should go here, right? Is it atom or is it molecules, right? Um, but that's really, all you're gonna see in chemistry, right? Because that's what we talk about. Are we talking about atom or are we talking about molecules, right? So we have 5.4 moles of H2O, and we want to know how many molecules of water, right? That's the question. How many molecules of H2O? Okay. So again, applying that, right? Drawing that division line and then seeing what goes on top, what goes on bottom, right? And we already have that true statement. That's why we generate that true statement first, okay? And again, I want you guys to be doing that, right? Before you even start the problem, right? Now, what should go on top? Molecules. So this number that's tied to molecules is going to go on top. Molecules of water. And what should go on bottom? 1 mole, right? Because we want the mole of H2O to cancel out. Okay. So let's do it. 5.4 times 6.022 double E 23. How many safe things, guys? That's 4. This is 2. So you're going to do 3.3 times 10 to the 24 molecules of water. Okay. Does that make sense, right? And let's start circling our answers too, right? To be clear. And this makes sense, right? I mean, this is a very large number, right? Times 10 to the 24th. That makes sense because we are asking how many molecules are in 5.4 moles, right? So you're gonna get a big number there, right? Now conversely, we can do it the other way around, right? We can ask how many um, moles and this time let's talk about CO2. How many moles of CO2 are there in 8.4 times 10 to the 25th molecules of CO2? Okay, well, let's get the equivalency, right? Earlier we were doing water, so our unit was 1 mole of water. Well, this time it's CO2, so I'll just simply replace this with CO2, right? And the number is still the same, and it's molecules of CO2. You see? So it's that simple, right? And then we execute. Once we have the equivalency, start with what you're given here, 8.4 times 10 to the 25th molecules of CO2. And what do you want out? Moles of CO2. Okay, so division line. Now what goes on top? What goes on bottom? We want mole of CO2 out. So 1 mole of CO2 is going to go on top. On bottom, 6.022 times 10 to the 23rd molecules of CO2, right? So that cancels 8.4 double E 25 divided by 6.022 double E 23. It's gonna be two sig figs, right? 'Cause you got four sig figs there, and you got two sig figs there. So 139 is gonna round to 140. Right? Right? This zero doesn't count. So 140 is only two sig figs, right? Only the one and the four. Okay. All right. We're gonna move on now to the next topic, but this is something that you guys need to practice, right? You see that we're going back between moles uh, and molecules, and then molecules mole, right? So that's something that you guys want to learn, right? And do lots of examples. So I'll go between mole and atoms slash molecules, right? It's by context, right? You'll know if it's a single atom, then it's atom, okay? But that is the first very important conversion factor that you guys need to be able to do, okay? I'm going to teach you guys the second. It's a second conversion factor, and it's called molar mass. All right, let's go back to the slides. Okay, so molar mass. What is a molar mass? It's a way for chemists to count by weighing. Okay. Um, because we can't see atoms, right? We cannot see atoms. We can't be like, oh, I need to do a reaction, but I need to grab, 1 million carbon atoms and I'm going to start counting carbon atoms. We don't have a way to do that. So the only way we can actually count atoms is by weighing them. Okay. And here's an analogy that, really illustrates how this works. Okay. So let's say that you guys, you're working in a hardware store, right? And a truck full of nails just came in. Okay. And your job is to figure out how many nails are in the truck that just arrived. Okay. Now you could count the nails one by one. Okay. But that's gonna take you all day, right? So what's a more clever way to count? Well, by weighing. Okay. So what could you do? You could take, one nail, right? And you can mass that nail and see how much it weighs, right? And then you can figure out the whole truck of nails, right? There's a way to put it on the scale and you have the whole weight of the entire thing. And so then you can take that number and divide by uh, one nail's mass and you'll have a number, right? So it's something like that, okay? But then you got to think, wait, perhaps, you know, maybe that's not the best way. There's even better way because each nail is not made the same way, right? They're not manufactured the same way. So they're going to have slightly different mass. So what you need to do is actually get the average mass of one nail, right? So count out 100 nails, okay? And mass that, okay? And then take the total mass, divide by that mass of 100 nail, right? And then divide by 100 again. So you basically average out the small differences in each nail, okay? So it's something like that, right? Now, when you are measuring out atoms, it's similar, right? Because um, what you're doing is, the atomic mass, the little number that you see underneath the chemical symbol, remember that was the weighted average of all the naturally occurring isotopes, right? So, in a way, that's what you're doing. You're averaging out, all the different mass of that element, right? All the different isotopes, right? They have slightly different mass, okay? And then what you do is, you use the mass of that atom to count it, right? So you go to the balance and you can figure out how many atoms, carbon atoms, for example, there are by using the gram number, okay? So this is what we call a molar mass. The element's molar mass is in grams per mole. And that's a unit that I want you guys to remember, right? Just repeat over and over again, right? Grams per mole. So what does that mean? In 1 mole of this atom, okay, is this many grams. So let's look at your periodic table and let's look at aluminum, right? Do you see that underneath aluminum, the number is 26.98? So that number is actually the gram number for 1 mole of aluminum. Okay, so 1 mole of aluminum is how much again, right? We just learned that it's this many aluminum atoms, right? 1 mole of aluminum is 6.022 times 10 to the 23rd aluminum atoms is equal to 26.98 grams, right? So we're counting by mass. So we go, if we know, we know that if we go to the balance and we put 26.98 grams of aluminum on the scale, we will have exactly this many aluminum atoms, right? 6.022 times 10 to the 23rd aluminum atoms, or 1 mole of aluminum. Okay, let's do it for another element. Everybody look at carbon and look at the number below, right? It's 12.01 grams of carbon for 1 mole of carbon, okay? Um, And again, that would be 6.022 times 10 to the 23rd carbon atoms, right? Let's go to helium. What's the little number below helium? 4.003, right? So that means in 1 mole of helium, it weighs 4.003 grams, okay? So now we can use, right, this equivalency, right? For example, 1 mole of carbon is equal to 12.01 grams of carbon. We can now put it, as a fraction to convert between moles and grams, right? If I have this many moles of carbon, how many grams is that, right? And vice versa. If I have this many grams of carbon, then how many moles is that? Okay. So let's go back to the board and we are going to um, do some example problems. All right, so this is our second conversion factor now, right? Going between mole and grams, okay, using molar mass. All right, so what if we were asked, and I'm going to do this example problem 2.7 um, on the slide there. It asks us to calculate the amount, let's look at it, right? Calculate the amount of carbon in moles, okay, in 0.0265 grams of pencil lead. Right. Of course, we know pencil lead is not lead, right? It's graphite. It's funny that we call it that. We obviously didn't know uh, chemistry back then, so it's not lead, right? It's just actually carbon. So that's why we're asked to calculate moles of carbon. Okay, so we know that we need to convert between moles and grams, right? That's the first thing you got to analyze when you're looking at these problems, right? What are the units that I'm converting between? It's moles and grams. And you're like, oh, well, what has moles and grams in it? Molar mass. Okay. Okay. And literally, that's what molar mass means, right? The mass in 1 mole. So you know that the unit is going to be grams per mole. So do it for carbon. What is it? Gotta make a true statement. Remember that. Don't even solve the problem until you have the full true statement. So you can say in 1 mole of carbon is how many grams of carbon? Well, where do you find that? The periodic table, right? All molar masses are on the periodic table. So 1 mole of carbon is 12.01 grams of carbon. Okay. Okay, so be specific. 1 mole of carbon is 12.01 grams of carbon. Now you're ready to calculate. So I have 0.0265 grams. I'm going to make a division line, and we are asking how many moles of carbon that is. Okay, so what's going to go on top? What's going to go on bottom? 4 moles got to go on top. 1 mole of carbon over 12.01 grams of carbon. Right? Grams of carbon will cancel. And we're going to punch in 0.0265 divided by 12.01. That's going to give us, and how many sig figs, guys? See, this is 4 sig figs. This is just 3, right? These zeros don't count. So I got to round to 3 sig figs is 2.21 times 10 to the minus 3 moles of carbon. Okay. All right. Let's do another problem. Back to our slides here. Okay. Calculate the amount of copper in moles of 35.8 grams of copper, which is Cu, right? So we want to know how many moles of copper that is. Right, back to the board. Okay, so we have 35.8 grams of Cu. Let me write that down here. It's a little bit of a glare. Okay, and we're gonna make that line, right? That division line, 35.8 grams of copper. We want moles of copper out. Okay, so we gotta come up with the equivalency, right? We need the molar mass of copper. Okay, where do we get it? The periodic table. What does it say? 1 mole of copper is 63.55 grams of copper. Okay. All right, so we need to put mole on top, right? 1 mole of copper over 63.55 grams of copper. So 35.8 divided by 63.55. Okay, how many sig figs should we have? That's 4 sig figs. This is 3. So it's going to be 0.563 moles of copper. Okay. So key thing, right? Key thing is to get the equivalency first. Okay. Where do we get a molar mass? From the periodic table, right? It's that simple. All right, let's go back to the slides and continue. Okay, now it's asking us, how many copper atoms are in a copper penny with a mass of 3.10 grams? Oh, this is, let me rewrite it. This is more multi-step problem, right? Because now you're gonna see that we're gonna have to go all the way to atoms, right? So really nice problem here for us to practice that. How many copper atoms are in a copper penny with a mass of 3.10 grams? Okay. All right, let's solve that on the board. Okay, so in these kind of problems, right, you can see that it's not just a single step because it's not just asking us to go from mass to mole. It wants us to go all the way to atoms. I always advocate writing out a plan first, okay? The plan tells you each individual step that you need to take to get to the final answer. Okay, we obviously want atoms, copper atoms at the end, right? Because it says how many copper atoms. So that's copper atoms, okay? And we need to get to here. But where did we start? We started at grams, right? We started at mass, grams of copper, okay? Needs to go to mole of copper, right? So this gram can go to mole through molar mass, right? And then from mole, you can go to atoms, right? Does that make sense? Okay. So now we execute once we have the plan, right? No, 3.10 grams. Do the line, right? Um, and then we need the equivalency here. I would just write it right on top of my plan, so I have it there, right? How do you go from mole to gram? Use molar mass. So look on the periodic table, right? 1 mole of copper is equal to 63.55 grams of copper, okay? And then what is the equivalency for mole to atom? We just learned that one, right? On top, 1 mole of copper is, it's a grouping, right? Of how many? 6.022 times 10 to the 23rd atoms of copper. Okay, so now we can execute. First, we go from gram to mole. So we're using this equivalency. Mole's got to go on top. So 1 mole of Cu over 63.55 grams of Cu. Okay, and that cancels, right? Okay, and then next conversion factor. We're now at mole. We need to go from mole to atoms. So right now, moles is on top, right? We want atoms out. So we want atoms on top. That's 6.022 times 10 to the 23rd atoms of copper per 1 copper. Okay. All right, you see that? Or we two-step problem, right? So 3.1 divided by 63.55 times 6.022 double E23. That's gonna be 3 sig figs. So you're gonna have 2.94 times 10 to the 22nd atoms of copper. Right? Okay. So I want to summarize this for you guys, okay? This is a way of problem solving that you're going to see over and over again in this class. So you need to be able to master using these two conversion factors to answer, any kind of question, okay? So I call this um, the roadmap, okay? So let me show you what the roadmap is. It's a great problem, a way for problem solving, right? It's a map for you to know, where do I start, where do I end, right? Now, in a problem solving, it's always asking for a question, like how many moles? That's where you end, moles where you end, right? And then there's always a given number. That's where you start, okay? So that's something that you need to identify right away. When you're reading a long word problem, right? That's how you orient yourself, right? Otherwise, you can't solve the problem. So the roadmap is a way, right, for you to be able to do that easier, right? Is to connect the steps so that it's, step by step, right? Because a lot of these are not just one step. The problems are going to get harder. You're going to have, multi steps, and so the roadmap is a way for you to orient yourself, right? In order to solve the problems. So oftentimes we start at atoms and molecules of A, right? And we'll convert to moles of A. Now, we just learned about the mole, right? The reason why mole is a unit that's used in chemistry is because it quantifies an amount, right? Um, and so, and all roads you're going to see are going to lead to mole in the roadmap, right? Because when we're doing reactions, we want to know how much, right? We want to know amount. We don't want to know the mass. We want to know how many mole of that thing do we need in our reaction, okay? And so we go to mole a lot, right? Now, how is it that we go from atoms and molecules to mole, guys? Using Avogadro's number, right? Okay. But in which direction? Do you guys remember? We want to go from atoms, molecules to A to mole of A. We're going to divide, right, by Avogadro's number. Okay. You can, if you want to go back, you want a mole of A to atoms and molecules of A. Of course, then you're going to have to do the opposite, right? Okay. But I'm really spelling it out here because it's not something you have to memorize, right? Because you can just use unit analysis to figure out whether you're going to divide or multiply, right? That's why you write the true statement, and then you see which unit you need to go on top, okay? That you actually don't need to memorize this, okay? But I'm just really just spelling it out for you here. And then you can go to grams, right? from mole, grams of A, or back, right? Okay. So how do you go from mole to gram? Okay. Of course, you need a molar mass, right? But what do? You multiply by molar mass. Okay. So from now on, when you see me write big M, that's molar mass. Okay. From gram to mole, um, you're going to divide by mass of A, right? Okay. And where do you find molar mass, everybody? On the periodic table. Okay. So here we go. Let's do another problem. Last problem we're going to do for this chapter that utilizes the roadmap. So you guys see how that works. Okay. So now I can ask how many um how many grams of CO2 are there in 7.2 times 10 to the 25th um, molecules of CO2. Okay. So in other words, if I have 7.2 times 10 to the 23rd molecules of CO2, that's a lot, right? How much does it weigh, right? How many grams is that? Okay. So remember, again, you're going to use, in these types of problems, you're going to do a plan, and you're going to use the roadmap to help you with the plan. Okay. So where do we start, guys? Molecules, right? You were given molecules. So we're going to start in this box here. Okay. And then it's going to ask us to go to grams. So we end at this box here, right? Grams of A. So that means we have to go like this first to moles of A and then down, right? So we divide by Avogadro's number and we multiply by molar mass, right? But again, we don't have to memorize that, right? Check how it's just, um, it's just really easy by using unit analysis to figure that out, okay? So let's write our plans. Molecules of A is now CO2, right? That's A is anybody, right? So CO2, molecules of CO2, we need to convert to moles of CO2. And from moles of CO2, we go to grams of CO2. Okay. All right. So let's do that together. Okay. We start at 7.2 times 10 to the 25th molecules of CO2. Oh, I'm not gonna have room. Let me erase the map for now. You guys have it, right? You're gonna have it in your notes. So you can be looking at that. But of course, the map won't be on the exam for you, right? So you're going to want to generate that map, memorize that map, and then generate it, at the beginning of the exam or something. Just have that handy. I think it's really useful. All right. So 7.2 times 10 to the 25th molecules of CO2. Okay. Now let's think about the equivalency, right? Molecules to mole. Remember that? That's Avogadro's number, right? But write a true statement. 1 mole of CO2 is equal to 6.022 times 10 to the 23rd molecules of CO2. Okay. All right. So which one on top, which one on bottom then? Since we want mole out, 1 mole of CO2 on top, 6.022 times 10 to the 23rd molecules of CO2 on bottom. Okay, so that cancels. And then one last step, right? Next step is going from mole to grams. We need a true statement for that one, right? How do you go between moles and grams, everybody? Molar mass, right? The mass in 1 mole. Where do you find molar mass? Periodic table. Okay. Now for CO2, it's quite easy to find the molar mass. Um, you know that the mass of one carbon atom is 12.01, right? Okay. Plus you need 2 times the mass of oxygen. Okay, so you have all the masses of each individual atom. If you add up all the masses of all the individual atoms, you'll get, the mass of the whole molecule, right? So 2 times 16.00, we're going to get 44.01 grams per mole or CO2. Okay. So then our equivalency is in 1 mole of CO2, there are, right, is equal to 44.01 grams, right? So get that equivalency going. Now you want grams out, so 44.01 grams of CO2 is on top, and on bottom is 1 mole of CO2. Okay, equal to, let's do this, 7.2 double E 25 divided by 6.022 double E 23 times 44.01. So sig figs 2, that's 2 sig figs here. These are 4. So we need to round to the least number of sig figs. It's 5.3 times 10 to the third grams of CO2. Okay, that makes sense. All right. So yeah, we've done those two problems where we're doing multi-step, right? So you guys want to practice that too, right? Go find a problem where you go from molecules to gram, and then the other way to go around, right? Grams to molecules. So you just get used to using these conversion factors, right? This one and this one in order to do your problem solving, okay? Get really good at that because you're going to see it over and over again.